let's take a look at the IR repeater circuit diagram. So as we've seen before, we have our IR receiver with one pin connected to 5 volts, the other to ground, and the signal pin to pin 11 on the Arduino. Next we have our IR LED with the cathode grounded and the anode connected via a 220 ohm resistor to pin 3 on the Arduino. Next we include our 3 push button switches. One end of each of the terminals of the switches are grounded. The other end of the first switch goes to pin 4 on the Arduino, the second switch goes to pin 5, and the third goes to pin 6. Of course, we have to connect the ground pin to the ground rail on the breadboard and the 5 volts pin to the 5 volts on the breadboard. That completes the wiring for our IR repeater circuit. Okay, now we're going to make the changes needed for our IR repeater circuit to finish up our project. We're going to add in the extra 2 switches. So for our next switch, we're going to add that in as close to this second switch as possible. Remember, one end of the switch goes to ground. Alright, so I will actually make a small jump here to this white wire which goes to ground, so I'll just connect these 2 switches together. Alright, that's essentially the same ground connection. The other end of my switch would go to pin 4 on the Arduino. So I'll go ahead and make that connection. Now I'll include the other switch, the final switch. Alright, again, one end of that switch is grounded, so I will ground that. And again, I'll go back to that same ground pin as the other switches used. And the other end of that switch goes to pin 5 on the Arduino. Alright, and we have to make a small modification from our first circuit. That initial switch was going to pin 12 on the Arduino. We're going to move that to pin 6 on the Arduino. Alright, so I know it's a little bit tight in there, but that completes our wiring, and it's compact so that we could actually use it as a remote, and we'll demonstrate that shortly. Okay, now I'll go ahead and upload the code for our infrared repeater circuit. As that's done, I'll go ahead and open up the serial monitor, and with our circuit we're able to record up to 3 infrared signals. So I'm going to use my remote here, and the first one is I'm going to record the power button to turn our TV on and off. So I'm going to push that. As you notice, it was received on the circuit, and I pushed the first button to associate it stored and now associated with the first button. Next, I'm going to record the volume up button. So I'm going to press that, and I'm going to tap on the second button. So as you can see, if I press on it and I tap on the second button, it's storing and associating with that button. And then finally, the volume down, I'm going to record that signal. So I'm going to push on that, and I'm going to record that volume down associated with my third button there. So now I should be able to play back these signals. So if I press the first button, you see it's sending the first power signal that I recorded. This one would be the volume up, and this one would be the volume down. Okay, so one thing to note is the way that our circuit works is if I remove power, so I'm going to disconnect my Arduino here, all right, to remove power from the circuit. We are actually storing this in EEPROM. So now I have no power applied to the circuit. All right, I'm going to, let me close off my serial monitor. I'm going to apply power again. Okay, and I'll open back up the serial monitor here so that you can see it. And now if I press the first button, all right, I still have that power signal stored, and the second is volume up, and the third is volume down. So very cool about our project, and it wouldn't really be a good remote if we couldn't store it, right? And if we lost all of our information when we removed power. So what you can do is, if you want to power the Arduino remotely, here I have a battery and a connector. So I'm going to connect this here to my battery, and I'm going to plug this DC barrel jack into our Arduino, and that's what we can use to power our Arduino remotely. And we will demonstrate how this remote actually works to turn the TV on and off. So here I'm connecting the actual battery to the Arduino, and I'm able here to power my Arduino remotely. As you can see, it's on, and we'll show how this can be used to turn our TV on and off and actually turn the volume up and down. Okay, so now I'm going to demonstrate to you how our infrared repeater circuit works. So this is our repeater, and I am going to point towards the TV. All right, and the first button here is which I associated with turning the TV on and off. So I'm going to point this infrared LED towards the TV and press it, and that should turn the TV on. So I'll go ahead and do that now. So here we go. All right, so our TV comes on. Alright, so now I'm going to change the volume on the TV, and I can use these two other buttons that I have associated with turning the volume up and turning the volume down. So here I'll go. I'm going to turn the volume up now. I'll point it towards the TV and press it to turn the volume on, up.
I want you to do something for me, Peter.
Alright, so now the volume is up.
I want you to try and relax.
Alright, and I'll use the other button to turn the volume down. So I had associated this button with the volume, the third button. So I'm going to point it to the receiver, to the TV. So I'm going to point it to the TV and turn the volume down. So here we go.
You're beginning to feel your eyelids getting heavy.
Alright, so there you can see the volume is going down, and I'll put it up again. So again, I'll point this towards the TV, point the IR towards the TV, press it, and here goes the volume coming up. Alright, so up, and then I'll do down again.
Count backwards from 3. You will be in a state of complete relaxation.
Okay, so the IR, our IR repeater was able to store the signals that we passed in, and is able to turn the volume up and down accordingly. And we can record any other signals on our remote and play them back to the TV. Now I'll go ahead and turn the TV off. So I'll press the power button, and here we go. So it all works. Let's dive into the code for our infrared repeater project. So at the top, we include a few third-party libraries. We have the IR remote library and the bounce tool library. And another library that we include is the EEPROM library that comes bundled with Arduino for writing and reading to the EEPROM. Next, we define a few global variables: our receiver pin, which is connected to pin 11 on the Arduino, and the status pin connected to pin 13. Next, we have our buttons. So those are connected to pins 4, 5, and 6 on the Arduino. We will incorporate the bounce library here to accurately detect when we push on buttons for transmitting IR signals and storing IR signals. So next we instantiate the bounce objects. You've seen this previously in some projects that we've done. Next, we set up the IR receiver and the IR send, as well as our decode results, global variable results, as we have seen in the last project. In order to store and associate readings or recordings, we created a struct here, and that struct has several different properties. We have the code type, the code value, the raw codes in case we have to store an unknown IR signal that doesn't conform to any of the predefined remotes, the code length, and the toggle, which is the RC56 toggle state. And we create a few of these struct variables, current recording, and then we have recording 1, 2, and 3, which are associated with each of the 3 recordings we want to store. Next, a few other variables. We want to record what the last button state is, the button state, and a boolean of recording complete, which we'll use further down below. In our setup, we start the receiver and we set the status pin as output. And for our push button switches, we enable the internal pull-up resistors. So we do that for button 1, button 2, and button 3. And then we attach the button pins to the appropriate debouncer objects. So here we do button pin 1, button pin 2, and button pin 3. Next in setup, we also do a get stored recordings. So I'll jump down to that function. And with get stored recordings, this is where we use EEPROM. So to make things simpler, we are saying in EEPROM, we're calling the get method on EEPROM, that object, and we're saying to start from memory location 0, and we want to place whatever we receive into the REC1 struct object. We also retrieve the second value that we stored from memory location 300, and we want to store that in the REC2 object. And then finally, we're getting from the memory location starting at 600, storing and placing that into the REC3 global variable object. So that's the get stored recording. Next, I'm looking at a few of the functions that we've seen before. Store code, this is exactly the same as we have seen previously. It essentially takes in a reference to that results object and stores the code when a signal is received. Send the code as well, that is similar to what we've seen before. It simply sends a code out. So basically, the only difference is we've modified this function a little bit to take in a recording, a struct, and in here we use that variable that we passed in and we send the appropriate code back out. So that happens when the button is pressed, one of the buttons on our circuits are pressed. If there's a code associated with it, it's sent back out. So in our loop function, we update the bounce instances for our push button switches, and we take a reading from those debouncer objects. If recording complete is false, here is where we want to check for press buttons. So essentially, if a signal was received and we have not yet stored it, this is where we wait to see which button was pressed to assign that signal to that button. So if the recording complete global variable is false, meaning it hasn't been stored yet, we check to see if debouncer 1 fell. If that was pressed, we want to associate with button 1, else if it's 2, we associate with button 2, or if it was button 3 that fell or was pressed, we associate with button 3. If a recording is complete, meaning else, that else part of that if check, then we want to transmit a signal. So basically, if the button 1 state is low, that means button 1 is pressed, we transmit for button 1, and then similarly for button 2 and 3, we transmit those signals accordingly. If the buttons were depressed, we have to re-enable our receiver. So that is one caveat with the IR library, is that we have to re-enable the receiver, after we receive a signal. So that's what we do here. We enable IRN. We call that method on the IR receive object. Also, we're checking to see here if an IR signal was received, and if that's the case, we're going to store that code and wait for the appropriate button press to determine which button that we need to associate with that stored code. Just a couple more functions below here. The transmit for button. So essentially it takes a button as an argument, and if it's 1, we are going to send the code for the first struct, or the first REC1 variable that we have. Else if it's a button 2, we do the second struct, or the third, it's the third struct. So that's just used to transmit the code for whatever button we associated with the particular data. So next we have the associate with button function. Again, it takes a button. So if button was 1, it would associate the current recording with the REC1 struct object. If it was 2, the second one. If it was 3, the third one, and so on. Set stored recordings is where we write to EEPROM. So instead of doing a get, we do EEPROM put, passing in the starting memory location and what we want to store. And then we do a EEPROM put 300, passing in the second struct, or the second recording, and at memory location 600, we pass in the third recording. These are just arbitrary, so I'll use the memory location 0, 300, and 600. They're just arbitrary memory locations, and that's where we decided to store the particular recordings at. So that's it. The main benefit here is that we're storing the actual recording in EEPROM and retrieving it from there. That way, if power is removed from the circuit, it would always be associated in memory on the Arduino. So there you have it. Let's take a look at the documentation for EEPROM from the Arduino website. So here you'll see all the different types of functions that can be called on that EEPROM object. So the ones we're doing specifically are the get and put. So I'll just quickly click on there. So for the get, here you see we call the EEPROM.get, passing in the start address, and this is the variable we want to store what was retrieved from EEPROM in, and that's what we did in our project as well. For the put here, it's similar to get, except you're going to specify again the memory location that you want to start at storing your variable, and here is what we want to store, the actual variable we want to store. So that's the difference between the get and the put. Get retrieves and put actually saves. So that EEPROM is basically on the microcontroller. They have about 512 bytes of EEPROM, and that's memory whose values are kept when the board is turned off. So you can think of it like a tiny, very small hard drive that we can store some information, not a whole lot of space, but nevertheless it's useful if we need to persist some information even though the Arduino is turned off. So that's the documentation for the EEPROM. Hopefully it makes it a little clearer on how it works and how we can use it. To summarize, in this project you learned how IR receivers work and IR LEDs work. You also learned how to connect them in a circuit. You learned how to incorporate the IR remote library to store and play back IR signals, and how EEPROM can be used to store information on your Arduino that is persisted even when the board is powered off. Infrared is an easy-to-use wireless communication technology that you can incorporate into your projects to allow you to remotely control your hardware components. You now have the knowledge on how this works and can inexpensively make your projects wireless. Let's move on to the next project.